Okay, I'm Dr. R. Muthukumaraswamy, Professor and Head, Department of Applied Mathematics. Now I'm going to explain the numerical solution of hyperbolic equation, that is one-dimensional wave equation. So the general form of one-dimensional wave equation, dou square u by dou t square equal to a square dou square u by dou x square. So this is one-dimensional wave equation. So here the constant a square is T by m, that is tension by mass. So it's a physical quantity. So it's a constant. Now this classification of PDE we are going to analyze. Let us rewrite this equation. A square dou square u by dou x square minus dou square u by dou t square equal to 0. You know how to classify? Classification here, the more general form, how to represent a dou square u by dou x square plus b dou square u by dou x dou y plus c dou square u by dou y square, etc. Okay, equated to something 0. So if the quadratic b square minus 4ac, that is, we can say the discriminant, the b square minus 4ac equal to 0, then it is, then the given PDE is parabolic. If the same thing, okay, the discriminant b square minus 4ac is negative, then it is elliptic. If b square minus 4ac is positive, then it is hyperbolic. Now we are going to analyze the hyperbolic model. So let us take this one, a equal to a square. We compare these two, then you are able to recognize the coefficient of dou square u by dou x square is a square. So capital A is a square, and the mixed partial derivative found missing, so b is 0. And now see dou square u by dou y square, instead of y there's a dummy variable t for wave equation model, so c is minus 1. So let us find out the discriminant of the quadratic form, b square minus 4ac. Now it is 4a square, which is nothing but positive since the constant a square is positive. Okay, so this comes under the hyperbolic model. So the given PDE is a hyperbolic PDE. That is, it's very clear, one-dimensional wave equation is a hyperbolic model. So you know the boundary conditions for any wave equation model, u of 0 comma t equal to 0. Suppose the string is initially at rest. Let us take a string of length L, okay, fixed at both ends. We are giving some force to set to vibrate, okay. Most of the cases the vibrations are sinusoidal. So in this case, initially both the ends u of 0 comma t, of course u is a function of x comma t, initially both the ends are at rest. So these two conditions are by default the initial conditions. Now the third one is a displacement u of x comma 0 is okay, I am taking some function for the given range 0 to L, alright, and then the velocity equal to 0. So for undergraduate level, for especially numerical problem while doing hand calculation, we are setting now velocity equal to 0. This velocity may be non-zero. In that case, the displacement function at t equal to 0 seem to be 0. Now our focus only on this particular model. Now I am going to derive the finite difference equation for the given one-dimensional wave equation. Okay, you know how to write the finite difference equivalent for dou square u by dou t square, or otherwise dou square u by dou y square. Okay, you know the finite difference equivalent for second partial derivative with respect to t. So ui j plus 1 plus ui j minus 1 minus 2uij by k square. Why? Because instead of t I am taking y. A square is a constant. So second partial derivative finite difference equal ui plus 1j plus ui minus 1j minus 2uij by h square. Okay, now I'm going to cross multiply, so the entire thing to the other side. So 2uij plus 1 plus uij minus 1 minus 2uij equal to a square k square by h square followed by ui plus 1j plus ui minus 1j minus 2uij. Okay, now I am going to set the lambda. Lambda is nothing but some constant, the step length k by h. Now what is k? Is nothing but step size along time direction or y direction. H is the step size along x direction. So that is what the basic idea. So I'll rewrite this equation. So uij plus 1 plus uij minus 1 minus 2uij equal to lambda square a square u I plus 1j plus u I minus 1j minus 2uij. So I'm going to combine now these two equations in a simple form. So uij plus 1 equal to, so 2 is a common, let us take these two are common. So 2 times 1 minus lambda square a square uij plus lambda square a square ui plus 1j plus ui minus 1j, and this term I am going to take to the right hand side. So minus uij minus 1. Okay, let us take this equation, the continuation of this. So I am going to dilute this particular nodal point to 0. So what to do? How I am going to dilute uij? We now choose the coefficient of uij is 0. That means I am going to take this particular coefficient set to 0. So 1 minus lambda square a square equal to 0. So therefore lambda square is 1 by a square. So substitute lambda square equal to 1 by a square in equation 1. Then the finite difference equation reduces to, this entire term completely tends to 0. Why? Because we are setting lambda equal to 1 by a. So this entire coefficient tends to 0. So you'll get this particular term is unity. So ui plus 1j plus ui minus 1j minus uij minus 1. So this is reduced form of the finite difference equation. I will call it as 2. Now so here the nodal points, it's very clear. If you take the nodal point as uij, so this is along x direction, and y direction the numerical value uij. If we take positive direction, yes, this is ui plus 1j, negative direction along x ui minus 1j, and positive direction along y axis uij plus 1, negative direction uij minus 1. So we are going to involve these 3 points according to the scheme. But this is, if this is given time level, I can calculate using only advanced time level. Now this is purely a negative time level. So how to overcome this problem? So this finite difference equation is incomplete. So what went wrong? So we are not incorporating the boundary condition that is given in this model in the beginning. Dou u by dou t x comma 0 equal to 0. That is, I am setting the velocity is 0 in this model, in this bookwork. Okay, so in this case I'm going to convert this partial derivative into finite difference form. I want to involve the points, especially these 2 points, my focus. So if you want to involve these 2 points, I'll go by the central difference formula. So I'm going to use central difference formula for time direction. So uij plus 1 minus uij minus 1, the step size along time direction is k. So the total distance is now 2k equated to 0. So in this case, the coordinate system x comma t, x refers I and here t refers j. So it's clearly given this particular coordinate, particular point is 0, that is your j is 0. If I set j equal to 0 in this equation, now I separate by comma, why? Because for better understanding, minus ui comma minus 1, otherwise this look like ui minus 1. So in order to avoid confusion, I have separated commas here, equated to 0, I cross multiply, so therefore you will get ui1 equal to ui minus 1 is the outcome of this velocity boundary condition. Okay, what to do? Now let us take equation 2. From equation 2, I am going to give j equal to 0 again. So therefore ui1, I'll separate it out commas, ui plus 1 0 plus ui minus 1 0 minus ui minus 1. Now I am going to substitute this ui minus 1 which is equal to ui1 in the right hand side. So ui plus 1 0 plus ui minus 1 0 minus ui1. So this side is also ui1, the left hand side. These two are same. I'm going to combine. So 2ui1 is ui plus 1 0 plus ui minus 1 0. By dividing or by simple algebraic manipulation, or simply divide, you will get here, divided by 2. So this is what very first time step in wave equation. So if you want to estimate numerical value in wave equation model, so you have to apply first time level, just average of these two nodal points. So that is what. After the remaining time level, I am going to use the finite difference equation 2. That is what the outcome of or the extract of this book work. For the first time step, apply finite difference equation 1, that is ui1, average value of ui plus 1 0 plus ui minus 1 0. For remaining time steps, I am going to use the finite difference formula. So the structure is, if this point is say for example uij, and the next advanced level uij plus 1, and this level is uij minus 1. Of course this point I have already explained, ui plus 1j, and along negative x direction ui minus 1j. I am just summing of these two value minus this value. While working out in table, you have to take the diagram in the reverse order. Why? Because this is a given time level, this is negative time level, advanced time level. So we are converting the entire thing into, for the first time level, separate finite difference formula. For remaining time level, this is what the formula. Okay, just this is very important, or the summary. Of course the bookwork is sometime out of scope, but these two results are very standard. Prior to exam, just go through this these two results. Okay, I will move on to the problem, how to tackle the problem using this finite difference formula. So solve dou square u by dou t square equal to dou square u by dou x square, 0 less than x less than 1. Of course time is positive, u of 0 comma t, u of 1 comma t 0, dou u by dou t x comma 0 0. And this is given displacement condition, prescribed length 0 to 1. Compute u up to first 4 time step. Okay, in this case how to proceed? Very important thing, what is a square? So you know that in this case a square, the coefficient of dou square u by dou x square, that is 1. So we can rewrite, so a square is 1, therefore a is 1, plus or minus 1. Of course we are taking only positive value since a is positive, that's why we are taking a positive value. And you know lambda is, we are assuming k by h, which is nothing but the lambda value is 1 by a. So 1 by a is k by h according to the bookwork. So if we set a equal to 1, therefore k by h equal to 1. I will rewrite, swapping these two terms. So therefore h step size are identical, k and h. Okay. So what is the material length here given? 0 to 1. So for hand calculation we can take the step size. So for 0 to 1, how to take step size? The two possible ways. One is you can take step size 0.25, 1 by 4, 0.25, 0.5, 0.75, 1, or otherwise you can choose step size 0.2, 0.2, okay, 0.4, 0.6, 0.8, 1. So the step size is your choice. Now for calculation point of view, I am taking the step size 0.25, sometime in the given in the question paper, or otherwise you have to assume. You know the very first step 1, how to proceed. For first time step, okay, the first time step, use finite difference formula ui1 of ui plus 1 0 plus ui minus 1 0. For remaining time steps, uij plus 1 is ui plus 1j plus ui minus 1j minus uij minus 1. Okay, so I'm going to form a table. Once you know this idea, once you know h is times step size along x direction and k is step size along time direction, both are equal. I am going to form a simple numerical calculation based on the values. Okay, so this is x and I am taking t. For reference, this is I and j. The step size, you know, 0.25, k along step size along time direction is also 0.25. Okay, now I am taking x, material length 0 to 1. So 0, 0.25, 0.5, 0.75, 1. Now at time t equal to 0, that's the initial part of the problem. Okay, now this entire boundary condition is given here at x equal to 0, completely 0, at x equal to 1 is also 0. So please, you have to observe very carefully. So this condition by default u of 0 comma t, x equal to 0, t equal to 0. So at this point the value u is 0. Okay, now x equal to 0.25. If we take 0.25, I am going to substitute in this equation x equal to 1 by 4, so which is nothing but, so 100 by 4 into 1 minus 1 by 4. So you know how to simplify numerically. This numerical calculation you can use calculator 18.75. Similarly, you take 0.5 or otherwise 1 by 2, substitute here, you will get very simple calculation, you will get 25. And next, if I substitute 3 by 4 or 0.75 in this condition, you will get 18.75. You can observe this one is preserved symmetry. Of course, this particular end extreme value 0, that is also given condition. So these two extreme values are given to you as 0. Now, so this is what I am calculating using the given condition. Now the numerical procedure starts. The next time level, I want to calculate up to 4 time steps. This is initial time step. Let us take 0.25, take 0, yes, this is going completely this. Let us complete time level, yes, first level, this is initial level, first level, second level, third level, fourth level. So I have to calculate up to this. Yeah, complete the table. Now all this are very clear. This is given to you. This side also you can fill up, yes, or you can fill up at the end also. Choice is left to you. You can do it. Okay. So this is what these two are completely given for any time level. These two conditions are set to 0. U of 0 comma t 0, u of 1 comma t 0. Now first time step, how to do ui1 average value of these two. So if I want to find out this value, what to do? Take the previous level. So if you are in say first level, 0th level is the previous one. So average value of these two. Don't take this nodal point. Why? Because this is reference uij, this is ui plus 1j, this is ui minus 1j. So according to our cases, this is 0th level, I plus 1 this node, I minus 1 this. Take average value of these two. It's nothing but 25 by 2, 12.5. Next, same way, if you want to find out this value, take average value of these two. You will get the value duplicated. Similarly, find out this value, average value of these two. So 25 plus 0 by 12.5. Okay. Now, this is very important. After completing the first time step, yes, I am using this finite difference scheme. Now, for remaining time steps, I have to use this finite difference equation. You should be very careful with wave equation model. It's very simple. Now, if you want to find out this particular value, so what to do? I am going to add these two according to the scheme. Add these two minus this 0. Okay. Next, if we want to find this value, sum of these two, now just ui plus I minus 1g, ui plus 1g, and negative time level, that's previously calculated, uij minus 1. So sum of these two minus this. Okay. If any doubt, okay, I'll draw the diagram for better understanding. Okay. This is ui minus 1g, ui plus 1g, and previous level ui j minus 1. So this is not a mesh approach, it's only for a tabulation point of view. So this is next time level, the previous level. Sum of these two minus this, that is what the scheme says. So sum of these two minus this 0, sum of these two minus this 0. Same thing you have to repeat using the finite difference scheme. True. Now sum of these two minus this minus 12.5, sum of these two minus this, yes, and if you want to calculate this point, sum of these two minus this, so 12.5. Repeat this for the next time level. Sum of these two minus this, yes, sum of these two minus this, yeah, sum of these two minus this. Yeah, stop at this stage. Why? Because that is what we want, 4 time steps. So how I am going to write the final answer? So u of 0 comma t, this is given to you 0. Yes, so here the value I have calculated is a slight mistake. So when you take these two minus this, okay, these two minus this, okay, I have calculated 18.75. So the solution for at x equal to 0.25 comma t, as well as this value u of 0.75 comma t or the identical value minus 18.75, and then the midpoint u of 0.5 comma t is minus 25. So this is what the final answer for this hyperbolic model. That's now we are going to solve problem using wave equation model with a different variety of problem. So as before, what do you mean by period of oscillation? So let us take what is period of oscillation. The formula for period of oscillation, I think I have studied in physics, 2L by A. So here the length of the material is given, and you know what is a square is clearly given here. A square is 16, therefore a is 4. So here length L is 5, therefore 2 into 5, 10, 10 divided by 4, the value, the numerical value is 2.5. So this is what the period of oscillation, the value 2.5. That means you have to estimate the numerical value up to t 2.5. That is what I expected, as we have done already. So lambda equal to k by h, lambda is 1 by a, yes, so therefore k equal to h divided by 4. So this is what the relation connecting k and h. Now the material length is given as 5, 0 to 5. So I am going to choose step size as 1. So if you take the material length 5, I am going to take 1, 2, 3, 4 and then 5. So you can take any number of points, but we are doing hand calculation. You can set better step size 1. So if I take h is 1, so k value is 1 by 4, so which is nothing but 0.25. For the first time step, you know the procedure, ui1 of ui plus 1 0, ui minus 1 0. We have done already. For remaining time steps, we are using finite difference scheme, ui plus ij plus 1, ui plus 1j plus ui minus 1j, okay, ui minus 1j minus ui j minus 1. I'll repeat, ui j plus 1 is ui plus 1j plus ui minus 1j minus ui j minus 1. So this is first scheme. Second scheme, for first time step you have to apply this finite difference scheme. For remaining time steps, yes. So we are going to calculate, since that I know the step size h is 1, I have calculated the step size along time direction. Yes. So the finite difference scheme we know very well. So we have done already. So the tabulation I have completed. So I'll explain now. The step size along x direction, the material length is 0 to 5. So I am taking step size 1, 0, 1, 2, 3, 4, 5. And time steps, of course, we have calculated time step 0.25, h and k. So the time step I start with 0, increment at 0.25, like that. I am taking up to 2.5, stop. Why? Because I want to find out the period of oscillation at t equal to 2.5. So this procedure is somewhat lengthy. Now from the given condition, just substitute x equal to 0, the finite difference, the given condition u of x comma 0 x square 5 minus x, give x equal to 0, the numerical value 0, that is coincide with the given condition. At x equal to 1, the numerical value 4. At x equal to 2, the numerical value 12. At x equal to 3, the numerical value 18. At x equal to 4, the numerical value 16. At x equal to 5, coincide with the boundary condition, yes, 0. So this is given to you from the problem. Now I want to calculate first time step. You know the procedure for first time step. Just take average value of these two. Ignore this point. So entire first column you know, and last column you know very well. That is already given to you. Now I want to calculate this value, this stage, taking average value of these two. 0 plus 12 divided by 2, 6. I want to calculate this value, 4 plus 18, so 22 by 2, 11. Next I want to calculate this value, 12 plus 16, 30, 28 divided by 2, 14. Next I want to calculate this numerical value, 18 plus 0 divided by 2, 9. So I am able to complete next time level by just taking average. Now I want to calculate the remaining time level. You have to use a finite difference formula, equation 2. So just recall from the previous lecture also. Now I want to calculate this value, sum of these two, right? Sum of these two minus this. So 0 plus 11 minus 4, 7. If you want to calculate this value, 6 plus 14, 20, 20 minus 12. So we are taking sum of these two minus a value from the previous level by ignoring this point. So we'll get 8. Like that we can proceed. I think we have to move up to this. So it is observed that initially all are positive and then there's a trend negative, again positive. You know very well, any vibration problems, you know very well, these vibrations are like this. Most of the problem, you may get positive values and then the trend is negative, again positive. So definitely the numerical values are like this. Now the final answer, the given boundary condition u of 0 comma t, you know very well, u of 1 comma t, 1 comma t, where t is 2.5, the numerical value is 4, u of 2 comma t, the numerical value is 12, u of 3 comma t, the numerical value is 18, u of 4 comma t, the numerical value is 16, and then at the end numerical value 0. So these two are given condition, the rest we are in a position to find out. It's a very simple model. You have to understand first of all the finite difference equation for initial time level and then for advanced time level. Basically this particular model is an explicit model. So what do you mean by explicit model? If we want to calculate one nodal point at advanced time level using the given points at known time level, is nothing but explicit formula. Okay, it's a standard definition. Okay, the method of finding out the numerical value at advanced time level using the known values from the given time level is nothing but explicit model. So what is implicit model? The implicit model is nothing but, if you want to calculate the values at advanced time level using the known time level as well as advanced time level, it will get a system of equation. You have to solve the system of equation that comes under implicit model. So implicit model basically is a Crank-Nicolson model. This particular scheme is called, that is this particular hyperbolic scheme is called Bender-Schmidt. Of course, for parabolic we are going to use Bender-Schmidt. We'll discuss later on Bender-Schmidt model.